Alright, so I am going to go through exam review 1, 2, 3, and 4. This is what I would have done if I was in school today, but unfortunately I am still at home sick, so I wanted to make sure that I still went over this with you though. So, exam review 1, we're doing mainly rounding, estimating, and then looking at exponents. So if we look at numbers 1 and 2, it says round to the largest place value to estimate. So with number 1, looks like the largest place value here is the thousands place. So in order to solve this, we need to round to the largest place value first, and then add our answer to get an estimate. So I'm going to come over on my scratch paper. So 3,620, that 6 is going to tell the 3 to round up to a 4. If you remember, when we round, everything to the right changes to a 0. Now this 4 is going to tell this 4 to round down or stay the same. So we're going to be adding 4,000 plus 4,000, which would give us 8,000. That would be our estimate. If it's asking for an estimate, we don't need to find the exact answer. Alright, same thing on number 2. Rounding to the largest place value. In this case, it's still to the thousands place. So here, that 6 is going to tell the 2 to round up to a 3. So 2,626 will round up to 3,000. And here, this 6 is going to tell the 1 to round up as well to a 2. So that'll be rounded to 2,000, and when we subtract, we get an estimate of 1,000. Okay, for 3 through 9, so the rest of the questions in exam review 1, or I'm thinking now this probably should have said 3 through 5. But it says to estimate the sum or difference and round to the place value indicated. This might have even just needed to say 3 and 4, but either way. For number 3, it says to round to the thousands place again. So that would be the 6 and the 5. The 6 will tell this 6 to round up to a 7, so 6,658 will be rounded to 7,000. This 2 is going to tell this 5 to stay the same. And then we would subtract, so 7,000 minus 5,000 would give us 2,000. So pretty much just the same thing we did in 1 and 2. And number 4, it tells us again to round to the thousands place. Now in this case, the thousands place is not the largest place value. The largest place value is actually going to be the 10,000s place, but this is telling us to round to the thousands place. So this 7 will tell the 1 to round up to a 2. Now the 5 is not going to change, but instead of 51,728, we're going to have 52,000. We rounded to the nearest thousand. Here, this 2 is going to tell the 3 to stay the same, so I'll just be left with 23,000. And I would add those together. Let me set this up vertically so it's a little easier to work with. Let's see, 2 plus 3 is 5, 5 plus 2 is 7. So our estimate would be 75,000. Now for number 5, it looks like, according to my answer key, this is just a straightforward long division problem. So when I have a question that's asking me to find the quotient, we know that quotient just means to find the answer. When we divide 1,078 divided by 21, finding the quotient just means find what the answer is. Now at this point in the semester, when we were first looking at long division, we were able to have a remainder or write our remainder as a fraction. Recently, we've been looking at dividing with decimals, in which we don't have remainders, but this is going back to when we initially were doing long division, and we will have a remainder, or we could. So again, when we have 1,078 divided by 21, that divided by number is going to go on the outside. That's going to be our divisor. 1,078 will be our dividend. And if you remember the steps to long division, we had dad, mom, sister, brother, rover. We would divide, see how many times 21 could go into either 1 or 10 or 107. We'd multiply, subtract, bring down, and repeat or get a remainder. So 21 can't go into 1, it can't go into 10. So we need to see how many times can 21 go into 107. Well, I know that 20 can go into 105 times. So I'm going to just try multiplying by 5 and see what that gets me. So 1 times 5 is 5, 2 times 5 is 10. That's pretty close to 107. So I'm going to multiply by 5. I subtract, I'll be left with 2, then I need to bring down that 8. Now I can tell that 21 goes into 28 one time. To get 21, I subtract and I'm left with 7. Now there's a couple ways that you could write your answer, and it depends on what the question's asking. If it doesn't give you a specific way to write it, then you could just say 51 remainder 7. But if it says to write it with the remainder as a fraction, remember we write 51 and it's the remainder over the divisor. So it would be 51 and 7 over 21. Now we could also simplify that fraction. So we would have 51, 7 divided by 7 would be 1, 21 divided by 7 would be 3. So that would bring it down to 51 and 1/3. But if it doesn't specify, I would be fine if you just write 51 remainder 7. Just be careful. If it's multiple choice, you should be able to see the way that they want you to write the answer. But if it doesn't specify, then you just do what you prefer. Alright, moving on to number 6. It says the 56 members of the service club divided into 8 teams. Each team had the same number of members. How many members were on each team? Okay, so we need to figure out, we're pretty sure this is going to be a division problem because it says they were divided into 8 teams. So we have a total of 56 members that were divided into 8 teams. We want to figure out how many members were on each team. So I would do 56 divided by 8. 56 members divided into 8 teams. Now you probably could do this in your head. We know that 8 times 7 is 56, but if you didn't, you could set it up this way and solve it. But there would be 7 members on each team. Okay, with number 7, moving on to some exponents. So we've seen some estimating and rounding, some division, and now we're looking at exponents. So this says to write this in exponential form. We know that if it's written like this, to write it in exponential form, all we have to do is count the number of digits that we're multiplying together, and that will give us our exponent. So I want to see, how many times am I multiplying 4? So I see 1, 2, 3, 4, 5, 6. I'm multiplying 4 by itself 6 times. So I would have 4 to the 6th power. 4 is my base number, 6 would be my exponent. Now number 8 is asking, what is the value of 3 to the 6th power? Now it's asking about the value. It's basically saying 3 to the 6th power is equal to what? If we were to solve it, what would it be equal to? So if I were to write this out, 3 to the 6th power, that means I'm multiplying 3 6 times. Now my suggestion when you're multiplying a bunch of numbers together, when you're solving, working out an exponent, just do a few at a time or a couple at a time. So I could do 3 times 3 is 9. 3 times 3 is 9. And 3 times 3 is 9. Then I could do 9 times 9 will give me 81. And then I would just have to do 81 times 9. I do 81 times 9. 1 times 9 is 9. 8 times 9 is 72. So the value of 3 to the 6th power is 729. When I work it out, I multiply these all together, I get 729. Now look at number 9. It says Lane sends an email to 7 people, and those 7 people send the email to 7 more people, and so on. Write an expression to show the number of people who will receive the email after the 5th round. So, to kind of put this in a picture, so we start with Lane. She sends an email to 7 people. And it said that each of those 7 people then send the email to 7 people, and so on. So we're wanting to figure out what kind of expression could I use. I don't want to write or draw all of this out. That would take forever. So what expression could I use to calculate how many people would receive that email after the 5th round? If you think about it, we start here. We have 7 people received it. Then they sent it to 7 more people each. So we kind of did 7 times 7. So if it's talking about after the 5th round, we could say 7 times 7 times 7 times 7 times 7. We multiplied 7 together 5 times. So we know an easier way to write this would just be 7 to the 5th power. We multiply it by itself 5 times. So my answer would be 7 to the 5th power. Alright, so that covers pretty much most of the material that we looked at, or a good number of the material we looked at in Chapter 1. I don't remember exactly how these chapters broke apart, but I do know that in Chapter 1 we for sure looked at estimating and rounding, long division, exponents. So now we're moving on to exam review 2. Get a new scratch paper. Alright, so it says for 10 through 12 we want to simplify each expression. Now simplifying an expression just means to solve it. Do whatever you need to do to get it down to one number. So for number 10, I have 25 minus 15 divided by 3. Now this is taking us back to our order of operations. If you remember, we used PEMDAS. And that tells us what order we need to go in when we are simplifying these expressions. So if you remember, we have parentheses, we would have exponents, then multiplication or division, then addition or subtraction. And if you remember, with multiplication and division and addition and subtraction, we do whichever one comes first between the two. So if we've got multiplication and division in one expression, we would multiply first, then divide. If we have subtraction, then addition, we would do subtraction first, then we would add. But we always have to do parentheses or exponents first before we move on to these. So in this example, we have 25 minus 15 divided by 3. We don't have any parentheses, we don't have any exponents, we don't have multiplication, so we're going to move on to division. So I would do 15 divided by 3 first, 15 divided by 3 is 5. And then the only thing left for us to do is to subtract. So 25 minus 5 would give us 20. And that would be your answer. For number 11, we have 57 minus 3 cubed plus 18. So again, I'm going to look at my order of operations, see what comes first. No parentheses here, but I do have an exponent. I have this 3 cubed. I need to do that first. With exponents, it would be a good idea to kind of come out to the side and work that out, showing your Scotch work so that we don't make any mistakes. So 3 times 3 is 9. Then 9 times 3 would give us 27. So I'm going to rewrite my problem. Rewrite the expression, so 57 minus 27 plus 18. Now here we have subtraction and addition left, and we know that between those two we just do whatever comes first in the expression. So if I'm looking left to right, I see subtraction comes first, so I would need to do this one first. I would need to subtract before I add. So 57 minus 27, you can probably do that in your head. But 7 minus 7 is 0, 5 minus 2 is 3, so that would give us 30. Then I'm just left with 30 plus 18, which would give me 48. For number 12, we've got a few more operations here. So I have 15 plus 30 divided by, and in parentheses, I have 25 minus 19 minus 17. Okay, so I really need to make sure that I'm paying attention and following my order of operations. I need to look and see, are there any parentheses? And in this case, there is. We have 25 minus 19, so that's what I need to do first. 15 minus 9 would give us 6. So I'm going to rewrite. I now have 15 plus 30 divided by, I'm done with the parentheses, so I don't need to keep them. I can just write a 6. Minus 17. Now I need to go back. I have addition, division, and subtraction. Based on my order of operations, division would come first. So I'm going to do 30 divided by 6. I know that that's 5. So I'm going to be left with 15 plus 5 minus 17. Again, between addition and subtraction, we just do whichever comes first in the expression, looking from left to right. In this case, I've got addition first. So 15 plus 5 is going to give me 20. And then I would just do 20 minus 17, which would give me 3. So make sure when you're doing those order of operations problems, you're simplifying these expressions, write PEMDAS on your paper if you need to, or on your scratch paper, so you remember the order of operations. Alright, now 13, 14, and 15 say to use mental math to solve these, and really what they're kind of getting at for you to do is to use properties. So if you remember, we looked at different properties of addition and multiplication. So you're not necessarily going to use mental math, but it's basically asking you just to think to some of the properties that you know to see if it can make this easier to solve. So for example, I'm adding 4 numbers together here on number 13. Now, I could line all these up and just add all 4 of them together, but we know that with the associative property of addition, we can group these together. So I can do 28 plus 9 first, then I can add to it whatever 32 plus 7 is. So 28 plus 9, I can probably do that in my head. I know 28 plus 10 would be 38, so one less than that would be 37. And I know 32 plus 7 is 39. And then here, if you needed to line these up, you could do that. 9 plus 7 is 16. And then that would give me 7. So my answer would be 76. So you're not quite doing mental math. I still don't know that I would suggest using mental math, and really there's no way that I would know if you use mental math or not. So I would play it safe and just show your work. But similarly on number 14, I'm multiplying 4 numbers together. So we could also use the associative property of multiplication to group these together. And it doesn't matter which way you group them. If you prefer to do 8 times 7 and then 2 times 5, you can do that. Those numbers might be a little bit easier to work with, so I think I'm actually going to do that. So I'm going to multiply 8 times 7 and 2 times 5. I know 2 times 5 is equal to 10. And 8 times 7 is 56. And we know when we multiply by 10, all we have to do really is just add a 0. So 10 times 56 would just be 560. But again, there's no hard and fast way to go about those. You can kind of do what works for you. And then number 15, 7 times 35. This is taking us back to a different property. So we're actually going to be using the distributive property here. We're going to break down this 35 into more manageable numbers that we can work with. So when we break it down, we want to think, well, what 2 numbers added together would give me 35? And try to think of numbers that could easily be multiplied by 7. So the first thing that I thought of was 7 times 30 plus 5. I think we'd agree that 35 is the same as 30 plus 5. And then you can multiply. You'll do 7 times 30, 7 times 5. Again, when we're multiplying by a number ending in 0, we really just have to look at the first digit. So we could do 7 times 3, which is 21, and then just add a 0. So that'd be 210. Then we know 7 times 5 is 35. Then all we'd have to do is add those together, which would give us 245. So the goal of these problems, when I ask you to do mental math, it's really just asking you to get these numbers in terms that are easier to work with. So for number 13, there probably might have been an easier way that we could have added these together to get easier numbers to work with, but that's essentially what it's asking. I don't know that there will be a question like that on your 9 weeks test that will ask you specifically to use mental math. But if it does, that's just what it's talking about. It's asking you to recall those properties and just kind of think back to how we could use those to make solving these expressions a little easier. Alright, so that is exam review 1 and 2. I'm now going to flip my page to exam review 3. Now this page has pretty much everything to do with expressions. So, starting with 16 and 17, it says to evaluate each expression to find the missing values for each table. So for this first one, our top row, remember, says what our value is for W. The expression is W plus 12. So in order to find out what goes in the bottom row, we take whatever W is equal to, so in this first case it's 3, and we plug it in. We would say 3 plus 12 would give me 15. So here W is equal to 4. So I'd say, okay, well what's 4 plus 12? That would give me 16. Here W is equal to 5, so I would do 5 plus 12, which would give me 17. For question number 17, we have a value for x on the top, and our expression is x divided by 5. So for this first one, if x is equal to 5, we plugged it in and said 5 divided by 5 is 1. For this next one, if x is equal to 10, 10 divided by 5 would give me 2. Here we have 15, and we know that 15 divided by 5 would give me 3. So that's all that that's asking. You're just plugging in the value for the variable into the expression that it gives you and filling in the table. Moving on to number 18. 18 says Jorge's family needs to find the area of their new garage floor. The length, which we say, or we use an L, is 34 feet, and the width, or W, is 28 feet. We want to find the area of the garage, or of the garage floor, using the formula area equals length times width. So it gives you the formula. So on our scratch paper, looks like I need another one, we're going to plug in those values into our expression, or our equation. So we're given area is equal to length times width. I like to write my L's in cursive so they don't look like a 1. And it tells me the length is 34 feet. So instead of L, I'm going to plug in 34. And the width is 28 feet. So to find the area, I would just multiply 34 times 28. So 4 times 8 is 32, 3 times 8 is 24, plus 3 is 27, 4 times 2 is 8, 3 times 2 is 6. When we add those together, 2 plus 0 is 2, 7 plus 8 is 15, and then 6 plus 3 would give me 9. So the area would be 952, and the way that we put our units with area, we say it's 952 feet squared. But if you just said 952, I would accept that. So we were just using this formula, using this equation, plugging in what we were given. Okay, looking at number 19. Says Jana wants to know, or knows the distance in miles and wants to find it in kilometers. So 1 mile, M, is about 1.61 kilometers. So if we had, let's say M was equal to 3. We have 3 miles, and we want to know, well, how much is 3 miles in kilometers? Well, we know 1 mile is about 1.61 kilometers. And we're not trying to solve anything. We just want to write an expression that she could use to figure out how many kilometers is any given number of miles. So you could take 1.61 and multiply it times M, or the number of miles. So if we were going to use 3 miles, we could just say 1.61 kilometers times 3. And that would tell me how many kilometers are in 3 miles, which I know already that it's about 5. But if you didn't know, you could use that to figure it out. For number 20, all it's asking you to do is write this, the product of 12 and 6, as a numerical or algebraic expression. So we're taking this expression in words and we're writing it in terms of numbers and symbols. So if you remember, if we see any of those key words like product, that tells me I'm multiplying. So if I want to write the product of 12 and 6, that means I'm multiplying 12 and 6 together. So that would just be 12 times 6. Now we know that we typically are wanting to use a different symbol instead of that X to show multiplication. So I would probably use this symbol for multiplication instead. It didn't ask you to solve it, it just said to rewrite this expression without words. For number 21, we're kind of going the opposite direction. We're given this expression, and it's asking us to write two word phrases. Now, if you notice, you might have seen this one before. I believe this same expression was on your Chapter 2 test. So here we have 15W. We know if we have a number and a variable pushed up together, that means we're multiplying. So you could say 15 times W. You could say the product of 15 and W. Or you could say 15 multiplied by W. The question was only asking for 2, so I would only expect you to give me 2 of those, but those are 3 different options that you could have used. That would have been totally fine. Alright, moving on to number 22. So this was probably one of the more challenging things that we did back in Chapter 2, was being given a table and having to find the expression that it represented. So if we look at this table, we have a number of gallons and a number of cups in that amount of gallons. So this is saying in 1 gallon we have 16 cups. In 2 gallons we have 32 cups. In 3 gallons we have 48 cups. But I need to figure out what expression could I use to figure out how many cups are in any given number of gallons. So that's where we had to look and say, okay, how did I go from 1 to 16? Well, I'm increasing, so remember there were 2 options. If we are increasing, that can mean that we're either adding or we're multiplying. So if I was adding, 1 plus what would give me 16? Well, 1 plus 15 would give me 16. Now remember, if that rule is going to work, it has to work with at least 3 of these numbers. If it doesn't, then that isn't the right expression. That isn't the right rule. So 1 plus 15 does equal 16, but 2 plus 15 is 17, not 32. So we're not going to be adding. So it probably means we're going to be multiplying. So 1 times what gives me 16? Well, anything times 1 is just itself, so 1 times 16 would give us 16. So maybe our rule is multiplying times 16. So 2 times 16, let's just work it out. 6 times 2 is 12. Okay, that works. 2 times 16 is 32. If I did 3 times 16, that gives me 48. So it looks like that's our rule. So I'm taking n and I'm multiplying it by 16. Any number of gallons that I could have, if I multiply it by 16, I'll get the right number of cups. Now we know that there's a better way to write this. When we're multiplying a number and a variable together, we can put the number first and just push the variable right up next to it. That shows that we're multiplying. Okay, for number 23 and 24, pretty much just doing the same thing. We're trying to write an expression that shows how I go from here to here. So again, going from 7 to 28, I'm increasing. So that means I could either be adding or multiplying. Now, 7 plus 21 would give me 28. So my rule could be y plus 21. Any number up here plus 21 would give me 28. So let's see. 8 plus 21 would give me 29. So that doesn't work. We can't add. So then we might have to multiply. So 7 times what gives me 28? Well, 7 times 4 would be 28. So maybe my rule is taking y and multiplying it by 4. Taking any number here, multiplying it by 4 would give me this number. So 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. So I know that this works. Any number times 4 will give me this answer. So again, my expression, I can rewrite it to have my number come first and show that I'm multiplying it by a variable. For number 24, I've got another one where I'm increasing. I'm starting with 10, I'm increasing to 31. Starting with 20, I'm increasing to 41. So again, I could either be adding or multiplying. So if I'm going to add, 10 plus something would give me 31. Well, I know 10 plus 20 would give me 30, so 10 plus 21 would give me 31. So I could be saying any number z plus 21 will give me this answer, but it has to work for all three. So 20 plus 21 would give me 41, and 40 plus 21 would give me 61, so that works. So z, any number z plus 21 would give me this answer. Now sometimes you might have to do two steps, so maybe you have to add and multiply, or you have to divide and subtract, so you've got to test those out. But I would start with those single operations, test addition, then test multiplication. If neither of those work, that probably means you're going to have to add and multiply, or do multiple steps. Moving on to number 25. For 25 and 26, it's asking you to determine whether the given value of the variable is a solution. In order for it to be a solution, that would mean 12 times whatever w is has to equal 144. Now you probably know in your head that 12 times 12 is 144. But we need to plug in this value for w to make sure that it doesn't work. So if I do 12 times 3, that would give me 36. But I'm supposed to get 144. So this is not a solution. So you could just write not a solution. Or it might ask you to write true or false, so this would be false. For number 26, we're doing the same thing. We're going to take 128 and add whatever value y is, which is 14, and we should get 142 if it's a solution. If we don't get 142, then it's not. So take 128 plus 14. 8 plus 4 is 12. 2 plus 2 is 4. 1 plus 0 is 1. And we got what we were supposed to do, so this is a solution. So this could be true, or let's say is a solution. Now 27 and 28, you've also seen before. This was on your Chapter 2 test. So it said in January, the total snowfall in Boston was 23 inches. The first storm was 7 inches. The second storm was 9 inches. Write an equation to find out how much snow fell in the third storm, or T. So for 27, you're supposed to write an equation, and then 28, you're supposed to solve that equation. So when I see that the total snowfall was 23 inches, that tells me that those three storms have to add up to equal 23. So the first storm was 9 inches, the second one was 7 inches, and the third storm, T, we don't know. But this is an equation we could use to find that out. So then for number 28, we would just solve. So this would be your answer for 27. 28, we would need to solve it. So let's start by adding these two numbers together. 9 plus 7 is 16. 16 plus t equals 23. We know to get a variable by itself, we do the opposite. So we're going to subtract 16 from both sides. And 23 minus 16 would give me 7. So the third storm, there were 7 inches of snow. Okay, number 29, we're given an expression. We need to write it in words. So kind of like we did on number 21. So remember, we want to be looking for those turnaround words, if there are any. So it says 5 less than x. We know than is a turnaround word. Means that what's in the back comes to the front, what's in the front comes to the back. And this less word means we're going to be subtracting. So 5 less than x, we turn it around, x comes first, we're subtracting 5. We're starting with x, and we have 5 less than x. Okay, so that's exam review 3. We're going to move on to exam review 4. So this is all, from what I can tell, all just solving equations. Hopefully this is going to be pretty easy. We've been doing this with decimals, so you've been getting a lot of practice just solving equations, but we'll work them out anyways. So 30 through 33, we're just solving these equations. Solving for the variable, trying to get it by itself. So for number 30, we have v plus 108 is equal to 126. Now we know to get that variable by itself, we have to do the opposite. So we're going to subtract 108 from both sides. That'll cancel it out on this side, so we'll just be left with v. Then we just subtract 126 minus 108. Going to have to regroup a little bit. 16 minus 8 is 8. 1 minus 0 is 1. 1 minus 1 would be 0. So v would be equal to 18. And we know to go back and check, we could just go plug in whatever we think v is and double check it. Add it and then see if we get the right answer. So 8 plus 8 is 16, 1 plus 1 is 2, 1 plus 0 is 1. That checks out. Now I'm not going to say you have to do that, but I think it's a really, really, really good idea. For number 31, we have 137 plus m is equal to 165. Now, personally, I like to see my variable on the left side, and we know because of the commutative property, we can switch these around and it means the same thing. So 137 plus m is the same thing as m plus 137. Didn't change anything, just moved it around. Again, we're going to be subtracting to get that variable by itself. We'll cancel out on one side. We'll be left with m, and then we're going to subtract. 15 minus 7 is 8, 5 minus 3 is 2, 1 minus 1 is 0, so m is equal to 28. Now for number 32, it looks a little bit different. We have 108 is equal to j minus 19. Now the only thing that's different about this is that our answer's on the left and our expression, our equation's on the right. We can turn these around. So we could say j minus 19 is equal to 108. It means the exact same thing. All we did was just switch these things around. That's what I personally like to do, but ultimately that is completely optional. Now here we're subtracting, so in order to get that variable by itself, we need to add. So we're going to add 19 to both sides. These are going to cancel out, we'll be left with j. And we'll add here, 8 plus 9 is 17, 1 plus 1 is 2, 1 plus 0 is 1. So J is equal to 127. Okay, looking at 33. We have F minus 49 is equal to 25. Again, we're starting with subtraction, so to get that variable by itself, we need to add. We do the inverse operation, so that leaves us with F, and then we just add on the other side. 9 plus 5 is going to give me 14, and then 1 plus 2 is 3, plus 4 is 7. So F is equal to 74. Now, looking at number 34, we are going to be writing an equation. We're not going to actually solve it, but we are going to write an equation that we could use to solve this one. So it says Jim removed 27 gallons of water from a rainwater storage tank. That word removed kind of sticks out to me, so I'm going to underline it. There are 59 gallons left in the tank. What equation can Jim use to find out how much water was in the tank earlier? So we started with a certain amount of water in this storage tank, and we took out 27 gallons. And when we took those 27 gallons out, we had 59 gallons left. So we took 27 from some number, and that gave us 59. Now with an equation, we don't have words, so we need to rewrite this so it looks correct. Now if we take 27 away from x, that means we started with x, and we subtracted or took away 27 from it. And that would give us what we were left with. So this equation could be used to figure out what we started with. Because if we have 59 gallons left, so let's say we put those 27 gallons back, that would give us what we started with. So x minus 27 equals 59 would be my equation. Number 35, we are going to solve for the variable. And it says 16 times h is equal to 128. This is really the same as what we did in 30 through 33, but we're just multiplying. So I have 16 times h is equal to 128. Remember, we have to use the inverse operation. So the opposite of multiplication would be division. So we would divide both sides by 16. We cancel it out here. Now I'm going to need to work this out because I don't know exactly how many times 16 can go into 128. And if you don't know where to start, I suggest just starting with multiplying times 5. And you can determine if you need to go up or down from there. So that gave me 80, so I can probably go higher. I'm going to try multiplying by 8. And looks like that works. 16 times 8 gives me exactly 128. So h would be equal to 8. Moving on to number 36. It says Follow picks 13 baskets of apples daily until all the apples are harvested. Her total yield is 234 baskets of apples. How many days has she worked? So she picks 13 baskets of apples per day, and the total amount of baskets is 234. So we need to figure out, if she picks 13 per day, how many days did she work to get 234 baskets? And it gives us the equation that we're going to use. We're going to use 13 times d, the number of days, equals 234. This is saying 13 baskets per day and we want a total of 234. So again, we're just solving for a variable. So here, again, we are multiplying, so we need to divide to get that variable by itself. Okay, we need to see how many times can 13 go into 2? It can't. How many times can 13 go into 23? Well, 13 times 2 would be 26. That's too much, so it can only go in one time. 23 minus 13 would give me 10, and I'll bring down my 4. Now I need to see how many times can 13 go into 104. Again, I would suggest maybe starting with 5. 3 times 5 is 15. 5 times 1 is 5 plus 1 is 6. Okay, that is pretty low, so I'm going to go up, I'll multiply by 8. 3 times 8 is 24. 8 times 1 is 8 plus 2 is 10, and that works out. So, how many days has she worked? Well, according to this, she worked 18 days. If she collected 13 baskets a day and worked for 18 days, she collected 234 baskets. So, D is equal to 18. I've got a few more left. 37 and 38, and really all of these, 37 through 40, we're just solving these equations. So 37, we have 17 times W is equal to 187. Again, we need to use that opposite operation. The opposite of multiplication is division. So we're going to do 187 divided by 17. I know 17 can go into 18 one time. Bring down my 7. 17 goes into 17 exactly one time. So W would be equal to 11. You shouldn't have remainders with these equations. I'm not going to say it's not possible to have remainders, but we haven't really seen many like that. Okay, our next one, we have W divided by 14 equals 7. Okay, now here I'm starting with division. So to get my variable by itself, I have to do the opposite of division, which would be multiplication. So I'll do 7 times 14. 7 times 4 is 28. 7 times 1 is 7 plus 2 is 9. So W would be equal to 98. For number 39, it says Palome shares grapes with 5 classmates. She gives 1 large bowl of 55 grapes to each person. How many grapes did she have? So she started with a certain number of grapes, and she shared those with 5 classmates. Each of those classmates got 55 grapes. So something divided by 5, the original number of grapes divided by 5, gave her 55 per person. So we're going to use this equation to figure out how many grapes did she have to start with. So again, our equation was G over 5, and we know if we see a variable over a number, that just means dividing. It's equal to 55. So something divided by 5 gives me 55. Again, the opposite of division would be multiplication. So we're going to multiply both sides by 5 to figure out how many grapes we started with. 5 times 5 is 25. 5 times 5 is 25 plus 2 is 27. So G is equal to 275. So she started off with 275 grapes. When she divided them to 5 people, each of them got 55. Okay, and then our last one, we have Z divided by 25 equals 12. So something divided by 25 gives us 12. In order to figure that out, we need to do our inverse operation, which would be multiplication. So we're going to multiply by 25. 2 times 5 is 10. 5 times 1 is 5, plus 1 is 6. 2 times 2 is 4. 1 times 2 is 2. We need to add those together. And we would get 300. So Z is equal to 300. So we just looked at all of exam review 1, 2, 3, and 4. We have already gone over 5 and 6 together. We did that on Monday, because remember, all of 5 and 6 was covering material from Chapter 3. So you should be able to review this and go back over your notes. Remember, your 9 weeks test is covering everything from Chapters 1, 2, and 3. So you need to make sure to review all of that information. If there's any concepts that you don't quite remember, you need a refresher on, you can go to Schoology and watch the videos. Those are still there and still available for you to watch. Don't forget, if you are doing a retake assignment, it is due tomorrow. It's due on Thursday. So if you are choosing to retake a quiz or a test, you should have found out what assignment needs to be completed. And you need to make sure to turn that in on Thursday. Turn it in tomorrow. That will show me that you have prepared and are ready to retake whatever quiz or test you chose. So for homework, you're going to be studying for your 9 weeks test and completing that retake assignment if you chose to do one. Now I am going to have an assignment for you to work on with whatever class time we have left. If you have questions as you're studying, please feel free to email me and I will do my best to try to answer those. Otherwise, just be prepared to come in tomorrow and take your 9 weeks test.